I made an experiment in Unity to help to understand what's the difference between update and FixedUpdate methods. In the corner, I leave you a link to an article on my website where you can download this Unity package ready to test. Let's make a brief introduction of the update and FixedUpdate methods. These are functions that are defined in the MonoBehaviour class. In our case, when we create a new script in Unity, we see the word MonoBehaviour in the definition. This means that this script is extending its behavior from the MonoBehaviour class, and therefore it will inherit certain parameters and functions that are defined in that class, such as the start, update, and FixedUpdate functions. In the description, I leave you a link to the MonoBehaviour's scripting API, where you will find all the functions and parameters that it has. So, Unity executes these functions automatically. The start function is executed at the start of the game. Unity will execute the start function of absolutely all the MonoBehaviours in the hierarchy, before the first frame is shown. The update function is called before every frame. If our game runs, for example, at 60 frames per second, update is gonna be executed 60 times per second. And the FixedUpdate functions, on the other hand, is executed in regular time steps, by default 20 milliseconds. We can see and change that value here in Project Settings, Time, Fixed Time Step. Currently 0.02 is the time between two consecutive FixedUpdate executions, about 50 times per second. Now let's see how the simulation works. In the scene we have a frame counter. This is gonna show us how many FPS the simulation is running at. And we have two cubes, one called update and the other called FixedUpdate. Both cubes have a script assigned to them called update FixedUpdate. This is script here. Then we have a game object called saturation that has assigned a script called create objects forever. This script is going to instantiate infinite cubes as children of this object and so start to saturate the simulation and produce a drop in the game FPS. Before running the simulation, I would like to quickly show you the scripts. Here we have the create objects forever script. For each execution of the update method, it will instantiate whatever prefab we assign in the inspector as a child of the game object to which this script is assigned. In our case, this game object. And the object that is going to be instantiated is a default cube. I made it a prefab here in the assets folder. The update FixedUpdate script will move the game object to which the script is assigned. In this case, this script is assigned to these two objects, the update cube and the FixedUpdate cube. So the script is going to move them in space. There is a public boolean called useFixedUpdate. This variable is going to determine if the movement is done in the FixedUpdate function or in the update function. For example, in the update cube, that box is unchecked, while in the FixedUpdate cube, that box is checked. Then we have a float called speed that indicates the magnitude at which these cubes are gonna move. As we see, we are executing exactly the same instruction in both functions. And here in the inspector, we make sure that the speed is exactly the same in both. In my case, 0.005. I'm gonna disable the saturation game object and run the scene to see how it works. Here we see that the game runs at approximately 180 FPS, and we see that the cube that is being moved in the update method does so much faster than the cube that moves in the FixedUpdate method. Now let's activate the saturation game object. When we enter the play mode, we see that the cubes begin to instantiate. Here the FPS begin to decrease, because now there is a graphic overload. Notice that if I zoom in on the object, Unity has a harder time drawing all these overlays of so many cubes, and consequently the FPS fall drastically. But if I deselect the object, the FPS instantly increased. So, what happens when the FPS starts to drop? The speed of the cube that moves in the update method begins to decrease, until eventually, when it moves too slow, the other cube that moves in the FixedUpdate functions overtakes it in speed. If we increase the saturation, we zoom in on the cube, we see that the cube that moves in the update method is practically stopped, because the simulation works at a very few frames per second. This is showing us that the update method is executed very few times per second, while the cube that moves with the FixedUpdate method does it with a certain lag, but the speed is preserved. This is why the FixedUpdate method is used for movements, animations, processes that need regular time steps, such as physical processes, while the update method is more convenient for performing logical operations. That's all I wanted to show you. Hope you find it useful and see you next time.